do a quick recap of the front page. So, a rational function. So if you look at the rational function, it's a quotient of two polynomials, p over q. A reciprocal is 1 over x. It's the simplest form. We talked about finding the vertical and horizontal asymptotes off the graph. And an asymptote shows where the function is undefined for the domain. The horizontal asymptote shows you the end behavior. We talked about a hole being an undefined point. So when you remove a factor, it creates a hole, and you can see it on your graph. And then we talked about the steps to analyze and graph it, that we need to find the domain right away before we simplify. And we talked about the horizontal, that if the degree on top is bigger, no horizontal asymptote. The degree is smaller, it's y equals 0. And if they're the same, it's power term over power term. All right, turn the page. We get to practice. So we're going to practice simple until we get more complicated. So I want you to look at number 1. What do we call that function? We call that a rational function. Why is it a rational? Because we have a polynomial divided by a polynomial. If you're good, you'd see that's a linear divided by a linear. Do you see that? Awesome. So what's the first step we're going to do? Factor. Yeah. Is there anything factorable there, or is it prime? Done. Step 1 finished. Check mark, right? Step 2, what's the domain? Where do I look? So I look at the steps and I go, wait a second. In my notes it says, state domain using the zeros of the... So when you're learning something, you haven't memorized it yet. You have to read your paper. And you practice enough until it's memorized. So how do you find the domain? The zeros of the denominator. So look at the denominator. What's the 0 of the denominator? So what can x not be? So x cannot be positive 5. Why is it positive 5? Because positive 5, take away 5 is 0. That's why it's bad, right? Undefined. Excellent. We're going to skip range right now. We're going to go right to the X-Intercepts. Where do I find the X-Intercepts? We have no common factors that remove. So step 3 and step 4 we don't do because there's nothing to remove. How do we find the zeros? Where do I go to? The numerator and the what? Multiplicity. So when I look at the numerator, what is the 0 of the numerator? Now you don't see it, but what exponent is there for x plus 1? What don't you see that's there? So because it's odd, what's going to happen at -1, 0? It's going to cross over. How do you find the Y-intercept? How do you find the Y-intercept? By substituting what in? 0. So if I plug in 0, what's 0 plus 1? What's 0 subtract 5? What do we end up with? -1/5. We'll estimate that on our graph. Vertical asymptote. The vertical asymptote shows where the graph is undefined. At what x value is it undefined? So at where is my vertical asymptote? Because that's where it's undefined. The horizontal asymptote. Look at the degree on top and the degree on the bottom. Is the degree on top bigger, the same, or smaller? If they're the same, you go power over power. What's the power term on top? X. And on the top, if it said 2x, the power term is 2x. Or if it said 3x, you'd write down 3x. But it's just what? X. What's the power term on the bottom? X. So x divided by x, where's the horizontal asymptote? At 1. So how did we find the horizontal asymptote? Power divided by power. Are there any holes in this function? Yes or no? Why not? There is nothing removable. Are there any holes in this function? No. Why not? There is nothing removable. Are there any holes in this function? No. Why not? There's nothing removable. We're ready to graph. So, now that we're ready to graph, how do I start it? Where's a good place? Where's my x-intercept? Let's go. Negative 1, 0. Where's my y-intercept? Now, that's silly, right? So just estimate it. Can you do that with me like I did it? Now, where are the asymptotes? I'm changing colors. So can you find where 5 is? 1, 2, 3, 4, 5. I found it. Where's the horizontal? Can you find 1 and put a horizontal? Notice I'm drawing a broken line as a symbol for the asymptote. So the vertical, you can't touch. You can't cross over. The horizontal, also, you may not be able to touch, but the horizontal gives me the end behavior. I want you to notice something. We only have how many points on our graph right now? So what I know is this. What I know is we can connect those 2 points and know the direction going to the left. So what is the left behavior? It's going to follow the what? The horizontal. I also know the right behavior is also going to follow the horizontal. And then what happens after that? Because it's underneath, where is it going to go? And I want you to curve it and recognize the direction it's going. At a vertical asymptote, it will either go to negative infinity or positive infinity. Because it's below the horizontal, where is it going? Next, x subtract 5. What's the exponent you don't see there? Because it is odd, and I'm going to write that right there, one end goes to negative infinity and the other end goes to positive infinity. So because I know one end, I now know the other end. The only thing I don't know that I need to find with the table of values is I need a point to curve through. So I'm going to pick a point over here. So I'm just going to pick one, and if it's too large, like if it's too high for my graph, I pick another one. I think 7 will give me a good point. I think 6 might be too high for my graph. So what happens when I plug in 7? What's my answer? 7 plus 1 is 8. 7 take away 5 is 2. So when I divide, what point can I add to my graph? See, there's a missing place on my graph where I have nothing to curve through. So can you find 7 and 4? So now I have a point to curve through. I want to make sure you understand the behavior around the asymptotes. What does the horizontal asymptote give you? That's where the ends are going. The very left arrow and the very right arrow are going to the horizontal asymptote. What happens at the vertical? It's either going to go up forever or down forever. In other words, is it above the horizontal or is it below, right? Gives you that indicator. Because the vertical asymptote was odd, one is below and one is above, they switch. And then I have to find one point where I had nothing to curve through to complete the graph. Now, when I look at this, I can tell that it's not touching or crossing over the horizontal. So the range does represent what y can't be. And so y can equal what number? 1. So if you tried to make the function equal to 1 and solve it, you couldn't do it. If you multiply both sides by x subtract 5, what's going to happen to the x's when you try to solve it? And what you're left with is, can 1 equal negative 5? We're not going to do that every time. But can you tell that y can't be 1? Because there's no answer for x. Awesome. We just did our first one. Woo! Number 2. You ready? Every time, the hope is, it's going to get better. So, let's see if you can help me through this. Danielle, are you ready? Step 1. On your sheet, what we wrote, on your desk, your notes. What does step 1 say? So step 1 is the factor, right? Have that beside your packet so that you can follow the steps as we go on. You ready? Danielle, is the top factorable? How should I factor it? So I'm going to factor out a 3. Is that right? And then the denominator, is it prime or factorable? Step 1 is done. Step 2. Thomas, what does step 2 say in your notes? Sit up for me just a little bit so it matters. Step 2.
State the domain using the zeros of the denominator.
Okay, what's the domain of this function? What's the excluded value?
-2.
Excellent. You just did step 2. Good job, Thomas. Now we're on to step 3, and maybe 4, and maybe 5. Rosie, what does step 3 say?
Remove any common factors that match in the numerator and denominator.
Look, is there anything that matches that can be removed?
No.
No. What does step 4 say?
If there are removable factors.
All right, step 4 is done. There's nothing. There's removal, right? So step 3 and 4, only if something strikes out. We're good. Step 5.
Using the simplified function, find zeros and multiplicity using a number.
Excellent. So what's the zeros of this function? Where do I look? In the numerator. So tell me the 0 using the numerator.
It's -1/3.
Not negative 1/3. Do you see we have 2 factors, right? So what makes the numerator 0? The 3, is there any 0 that comes from the 3? No. How about the second factor? -1. So where's the X-intercept? Do you know if the X-intercept's odd or even, the multiplicity? Do you know why? Because the exponent you don't see, right, is odd. Why does it matter? Because it's odd, it's going to cross over. Yes? Awesome. Kimberly, what is the next step? What are we at? Step 6?
Using the simplified function, find the Y-intercept by substituting 0 into the function.
All right, can you do that for me? Wherever there's an X, plug in 0 and tell me the answer. What do I mean? So I mean to find the Y-intercept, wherever there's an X, plug in 0 and solve it. That's what I mean.
Okay, so the numerator is 3
Yes.
and the denominator is 2.
Now, some of you, if I said plot the point 3/2, would go, I don't know where that is on my graph, right? So what's a better way to write that so I know exactly where to put that on my graph? What is 3 divided by 2? Kimberly. 1.5, right? So if I said, hey, where's 1.5? Could you find that on a graph? Is that better than the number 3/2 on a graph? So we're going to say the Y-intercept's where? At 1.5. Is that cool? We're now at step 7. Is that right?
Yeah.
Lizbeth, what's step 7?
Find the vertical asymptote using the zeros of the simple.
Good. Where's the vertical asymptote? The zeros of the denominator.
At -1.
At where? Did you look in the denominator?
Oh no, -2.
Yes. So where's the vertical asymptote? At -2. Is it an odd or even vertical asymptote?
It's an odd.
And you know why that matters? Is that one side is going to go up forever and the other side's going down forever. So if I know one side, then I know both sides and their behavior. Yes? All right. Jocelyn. I know. Some mornings are better than others, right? What is the next step asked for you to find? Where are we at? 8? 9? 8. What does step 8 say?
To find any holes.
Nah, no holes. Why no holes? Nothing's. Why no holes? Why do I know there's no holes? Because there's nothing. What's the R word? Is there anything removable? Did we remove anything? No holes. Skip the step. Yay. Next step.
Find the horizontal asymptote.
Oh, how do I find that? Oh, it's a long one, isn't it? Can you tell me, Jocelyn, I'm going to help you through, what's the degree of the top? Do you know what when I say that? Do you know what I'm asking for?
Yeah,
You're going to give me a number. So what's the degree of the top? 1. What's the degree of the bottom?
1.
Well, you don't know. They're the same, aren't they? So when they're the same, how do I find the horizontal asymptote? Is I go power over power. So what's the power term on top?
1.
No. And to find the power term, it's not the factored form, but the expanded. So what's the term with the biggest exponent?
3x.
That's right. 3x, and the 3 matters. What's the power term on the bottom?
X.
So when you divide, what am I left with?
3.
So the horizontal asymptote is where?
3.
At 3. Excellent. Now we're going to start graphing. Sarah, how should I start this graph?
With your X-intercept
Good. Where's that?
at -1.
Good. Can you find that? Put that on there. What else can I put on my graph?
Your Y-intercept
Which is where?
1.5.
So can you find where that is approximately in the middle of between 1 and 2? And what else can I put on my graph?
Your asymptote
So one asymptote is where?
at X equals -2.
So let's find that. There's -2. Where's the other one at?
Y equals 3.
All right, let's find that one. If you have one vertical asymptote, it separates the picture into 2 curves. If you have one vertical asymptote, it separates the picture into how many curves? 2, right? So if you look carefully, we actually have 2 points on the right, but nothing on the left. So we're going to start on what side? The right side or the left side? Good. Now, what do we know about rationals? Is the horizontal asymptote gives us what, Pedro?
Can you repeat that again?
The horizontal asymptote. What does it give us on the graph? The horizontal asymptote gives us the end behavior. So what does the horizontal asymptote give us? The end behavior. So do you see these 2 points that we know? Guess which way it's curving. Where is the arrow going to end up? To the right. It's going to end up right beside the what? Because the end behavior is the horizontal asymptote. The end behavior is the horizontal asymptote. Now, what do you think happens to the curve as you're going to the left? So to the right, it goes to the horizontal. What happens at the vertical? It only has 2 options. It's either going to go up forever or down forever. Where's this one going? Do you know why? Because it's below the horizontal asymptote. So, and you can see the 2 points it's guiding you, right? Do we also know it crosses over the x-axis? Right? So everything is guiding you in what direction? Right? So, do you see how we finished one curve? Yes. How many curves do we have? 2, right? One on the right side and one on the left side. What type of vertical asymptote is it? Is it odd or even? Why does it matter? Well, if one end is going down forever, because it's odd, the other end must be up. And you know what else I know? What's the end behavior? I know the end is going to be where? And here. What don't I know that I need to find still? Is a point to curve through. So we need to pick an x value to the left. Give me an x value. Pedro, give me an x value. So, let's try -4. And how I know, listen, how I know that's a good x value is if that point I can show on my graph. If it ends up being like 300 or something, I got to pick a different point, right, that's on my graph I can curve through. So if I plug in negative 4, I have 3 times negative 4 plus 3 and negative 4 plus 2. Can you see how I took out an x and substituted in negative 4? Can you simplify that? What's negative 12 plus 3? Oh, you got to be with me. Dan, you ready? What's negative 12 plus 3? Negative what? 9. And what's negative 4 divided plus 2? Now, we know this. A negative divided by a negative is positive. What's half of 9? That's right. So where can I go on my graph now? Negative 4 and what? 4.5. So can we find that? Negative 4 and 4.5. That's a perfect point, isn't it? It's right there exactly where we need to be on our graph. Do we now have a point to curve through? Can we now complete the curve? Do you see where the ends are going? Do you see the behavior at the vertical asymptote? Do we have a point, at least one point, on both sides? And again, with one vertical asymptote, how many curves are we going to have? 2, right? Now, in this case, we are not crossing the y-axis. I mean, we're not crossing the horizontal. So for the range, it's the horizontal asymptote. So what can y not be? 3. We will have examples where the cross is over, but this is not one of them yet. Man, you know what the good news is? We still have an hour to do this work. Just kidding. We still have 20 minutes to do this. We have more to do. And you know how you're going to learn this? And when I look out and see that you're not paying attention, right? You're trying to wake up, I'm going to call on you so you can be famous. So when you watch this lesson video, you know I called on you. So number 3, we're going to follow the steps. Nancy, here we go. Not by memory, because you haven't memorized anything yet. By looking at your notes, what's step number 1? Yeah, look at the numerator. Take your time. Tell me how I should factor the numerator. Oh, just Nancy. Remember how you learn something? Is by practicing with great attitude. And practicing correctly, right? Like you have me. We're not making mistakes. And we're going to get somewhere. All right, Nancy, tell me how to factor the numerator. You got x plus 3 and x subtract 5. Did I hear that correctly? Perfect. You did step number 1 correctly. I'm going to ask someone else for the next step. All right, step number 2. Who to ask? Kaylin. What's step number 2? So what's the domain? Where do I look for the domain? Okay, so tell me what it is then. So you're telling me all real numbers but x cannot equal negative 3. And you know why x cannot be negative 3? Because it makes the denominator 0. Yes? Awesome. Thank you, Kaylin. Marilyn, what do I do next? Do you see any removable factors? What do you see removed? Listen carefully. Is there a hole in this function? Yes. Why? Because there's a removable factor, right? If we remove something, there's a hole. Excellent. What's left over after we remove it? Beautiful. Okay, next step. Where are we at? Step 4?
Yes.
Genesis, what's the next step? Say that again? Good. So is there a removable factor? So is there a hole in our graph? Okay. Do you know where the hole in our graph is at? What did we remove? What's the 0 of what we removed? So at what x value is there a hole? Do you know how I'm going to find the y coordinate for my hole? Is I take the x coordinate and where do I plug it into?
The X.
So what remains, right? The simplified one, I take that x coordinate, I plug it in, and what answer do you get for the y value of your hole? All right, let's continue. Eduardo, what's the next step?
Using the simplified function, find zeros and multiplicity using the numerator.
Can you tell me what the 0 and multiplicity is of this function? Now, I want you to notice that in this situation, our denominator, Eduardo, is 1. So if I'm looking at the numerator, what am I looking at? X subtract 5. What's the 0 that comes from there?
5.
And is it odd or even?
Odd.
Excellent. What does that mean? Why does it matter? So at 5, it's going to cross over. Excellent. We're getting there. Clarissa, what's the next step? On your paper, what's the next step after finding the x-intercepts?
Using the simplified function from the y-intercept.
Good. How do I find the y-intercept, Clarissa? Yes. Can you tell me the answer when I plug in 0? Excellent. You just found me the y-intercept. The y-intercept is at -5. Let's look at the next step. Davian, what's the next step?
Find vertical asymptotes using the zeros of the simplified denominator.
So, I was trying to get this in here. Look at this carefully. What's left in the denominator?
1.
Is there any vertical asymptote there? Like, in other words, look at the zeros of the denominator. We don't even have a variable left, right? There is nothing that will make the denominator 0, correct? It will always be 1, never be 0. So, guess what? We have no vertical asymptote. Is that right? Excellent. Let's look at the next one. Isn't that crazy? No vertical asymptote. Keep going. We got this. Claudia, what's the next step? Did it say find any holes? Hey, we already did that. Next step. We have a hole at -3, -8. Next one. If it exists. Can you tell me the degree on top and the degree on the bottom? So, if I look at x subtract 5, the degree on top is 1. And when you don't see a variable, the degree on the bottom is 0. And the big point is the degree on top bigger, smaller, or the same? Bigger, right? If the degree on top is bigger, no horizontal asymptote. What the hey, right? Let's do this. So, what can we graph right now? Well, I know how many points do I know? So when I graph it, I'm going to start at 5, 0. 1, 2, 3, 4, 5. Can you do that? What else do I know on my graph I can plot? 0 and what? -5. Awesome. What else do I have to put on my graph? Do you know where the donut goes? The little Cheerio?
In the middle. Oh wait, no. -3 and 8.
Can you find where that is? -3 and -8. Thank you.
Oh my god.
You're right. Now, if I asked you to graph x subtract 5, you just graph a slanted line. We have it, right? We don't have a horizontal asymptote, so the ends aren't going to that. Instead, all we're graphing is we're graphing a line, but what makes the line special is there's a hole in it. And to graph a slanted line, we only needed 2 points. The hole can also act as a point to guide your line or your slope. So what is the range then? What's the only y value it cannot be? Is what? Not -3, but negative, oops. What's the bad y value? -8, right? So x can't be -3 and y can't be -8 because it's an undefined point. What? We're at number 4. You guys are just moving along. You know, if you feel grumpy and tired, it makes it more challenging. But you know what? I push through. Here we go. Number 4. Let's find these steps. Number 4, especially if you look tired or grumpy, I'm going to call on you. So number 4. How are we going to do this? All right. Aaliyah, can you start me off? What's step number 1? Can you see anything factorable?
Yes. The numerator.
Tell me how to factor the numerator.
X plus 2 and x minus 2.
That is awesome. Thank you. Step 1 is to factor. Step 2, Jessica.
State the domain.
What's the domain?
All real numbers except for 2.
Exactly. And you know where you found positive 2 is in the denominator. Alyssa, what do I do next? Yeah, are there any removable factors here? So because a factor removed, what's on my graph? A hole. And what's the 0 of what I removed? So at positive 2, there's a hole. And what's left over after you remove it is just what? X plus 2. And if you want, you can put what in the denominator to help you through the steps. So how do I find the y coordinate of my hole? So if I plug in 2, obviously 2 plus 2, where's the y value of the hole? So can you find it right there? And then here, 2, 4, there's my hole. Excellent. Richard, what's the next step? Keep working. Try to work one step ahead of me. Challenge yourself.
Find the zeros.
Good. What are the zeros? And where do I look to find the zeros? Numerator or denominator?
Numerator.
So in the numerator, what's the 0? What is it? Is it odd or even?
Odd.
And why does it matter? Because at -2, it's going to cross over. Keep going. What's the next step? Michael. We just found the zeros. What's the next step after finding the zeros?
Using the simplified function, find the y-intercept.
How do you find the y-intercept?
Substituting 0 into the function.
So if I plug 0 in, what's 0 plus 2?
2,
So where's the y-intercept?
0, 2.
Excellent. Let's keep going. K. Is there a vertical asymptote for this function?
No.
Is your name K? K. Is there a vertical asymptote? And you know why? Look at the denominator. What's left in the denominator? Is there any way to make the bottom 0? So there's no vertical asymptote. Thomas, is there a horizontal asymptote?
No.
Why? Because the degree in the numerator is? No.
No. One's bigger, right?
The top is bigger, isn't it? So when the top is more powerful, when the degree on top is bigger, there is no horizontal asymptote. We're ready to graph. Melissa, how should I start my graph?
By plotting the holes.
I can plot the hole. I like doing Cheerios. So 2 and 4. There's my Cheerio. What else can I plot?
So x and y.
Where's that?
The x is at 0, 2.
The x is at -2 and the y-intercept's at...
The y is at 0, 2.
Do you see how they all line up? So we're done. Can you draw a line? But when you draw a line, don't draw it through the hole. You got to hop over the hole. I know, right? Like when you draw the line, don't strike through the hole.
I already did that.
Don't do it. So when you draw a line up to the hole and then you hop over.
Oh, I thought
You got it? So don't just draw the line through the hole. Hop over it. Got it?
Sure.
All right, here's our last one for today. Turn the page. Number 5. Huh? What? I didn't do the range. What can y not equal? It comes from the hole. What's the y value of the hole? Done. Okay, number 5. The fun part about being in this room is you hear the shower bell, right? That's only for the ones that are like sweating. So, not for us. Number 5. We get to keep working to the bell. So, let's try one step at a time. Cristobal, help me. Step 1.
Factor the numerator is the denominator.
Okay, so the numerator is prime. What do I do with the denominator?
Is 6 and 1.
Okay, so which one's positive, which one's negative?
6 would be positive.
So what I'm challenged with is that 6 and negative 1 make negative 6. So we need 2 other numbers. 2 numbers that multiply to 6, but they add to 5. Not subtracting. Adding to 5. So what are the numbers then?
3 and 2.
So negative 2 and negative 3. Is that right? Does that match?
Yes.
Good. Step 2. Evelyn, what do I do?
State domain using the zeros.
Good. What's the domain? What can x not be? Nope. And? Look at the denominator. What's the zeros? 2 and 3. Beautiful. Next step. Jimena, what do I do next? Do you see anything removable? So I'm going to remove it. What's left is 1 on top and x subtract 2 on the bottom. But because something removed, what do I have on my graph? A hole. What's the zero of what you removed?
3.
Jimena, what's the zero of what crossed out? 3. And to know how to find the y coordinate, what do you plug in for x to find the y value? So I plug in 3 for x. Could you solve that? Which equals? Perfect. So where's the hole? At 3 and 1. Next step. Anthony, what's the next step?
If there are removable factors, they are old in your graph.
Hey, I did the hole already. Next step.
Using the simplified function, find zeros and multiplicity using the numerator.
So, look at the numerator. What's in the numerator? So, is there anything that makes the top 0? No. There are no X-intercepts. Because nothing makes the numerator 0. No X-intercepts. What's the next step after that, Corey?
After that, using the simplified function, find the y-intercept between 0.
Okay, do that. So plug in 0. Tell me what the y-intercept is. Correct. So the y-intercept's at negative a half. Let's keep going. Who haven't I picked on? Amelia, what's the next step? I'll circle it. What's the next step? And I look in the denominator. Can you tell me the 0 of the denominator? And it's odd because the exponent you don't see there is 1, which means one end goes up and the other end goes down on either side of it. Horizontal. I'll do that one. Do you notice the top is weaker? That means when the top is less or the bottom is more powerful, it's always y equals 0. We're ready to graph. So I have a point at 0 and negative a half. I have a hole at 3 and 1. I have a vertical asymptote at 2. And I have a horizontal one at 0. How many curves will this be? Because we have a vertical asymptote, we have 2 curves. And what do I know about it? Well, I know the end behavior is going to what number? So both ends are going to 0. And then what happens after that? What's the behavior at the vertical asymptote? It's either going to go to infinity or negative infinity. So the one below the horizontal, what direction is it going? And the one above, what direction is it going? The other way? And you just finished it. The hole can act as a point that you curve through, even though you're hopping over it. So the range, what y cannot be, is 0. Oh, what's the other one it can't be? What's the y value of the hole? So 0 and 1. All right. Hey, we're done. First 5. Mr. G Math.